guys, Jason here. Just going to quickly take you guys through my Excel report for Module 2. So here we go. So in this first problem, we went over a possibility survey, and in that we recorded answers for no, answers with yes that were women, and answers that were yes and that were not sure that were also men. And with that, we recorded it in fractions, simplified fractions, decimals to the nearest thousands, and percent to the nearest tenths. In addition to that, we also broke apart the men and the women population factor between the survey as a whole. Okay, and in this problem, we're going to look at products and sums of rolling two dice. And with it, we also made 4 tables, as you can see here, that all accurately depict the amount of possible plays that you can get for each of those dice. And we took into account by looking into sums of 2 and sums of 3, as well as prime numbers and multiples of 12. Okay, and this problem was very interesting. It is a table of a possible lottery ticket sell, and with that, you're able to see the amount that they could possibly lose by doing nothing, which is 0, which means they're in the negative $5. And because of that, you can also see the possible maximum amount, so to speak, that they could possibly make in a given setting. And with that, we also used to compute the gross income that a salesman could get by selling at least 5 million of those lottery scratch-off tickets. And it resulted in over $3 million. Okay, and in this problem, we went over the odds against and odds in favor of a given event. And with that, we also calculated in fractions, simplified fractions, decimals to the nearest thousands, and percents to the nearest tenths. And with that, we also showed it in a bar graph with odds in favor having the highest of the 25% and odds against were the lowest at about 50. And we also incorporated new, and I'd categorize it as close to similar like a scatter plot diagram, I guess. And there's this problem. And in this problem, we went over the population differences between men and women in all the 5 branches of service. Sorry. And with that, we also took into account the percentage of men and women in each branch of service, which were attributed to the Army, the Navy, the Marines, the Air Force, and the Coast Guard. And once we acquired those percentages, we also put it all over into a bar graph, as you see here. It accurately gives each branch's percentage for male and female service members, as well as the total for each branch. And with that, we also calculated the number of women in the Air Force, the Marines, and the Coast Guard here, which came out to roughly 1.7, or we have 1.7, or at least 14.4%. We did that same process again to the Army, and all of which that were men, and we came out to roughly about 70.5%. And again, with those that were not Marines, that were women. And we came out to about 6 4/9, I believe. And lastly, we did that with men who were also in the Air Force, and we came out to about 293.9%, I believe. And the last problem that we had was we had to breakdown the specifics of a binomial experiment, and which meant we had to satisfy at least 4 positions, 4 of which were being a fixed number of trials. Each trial is independent of the others. There are only 2 outcomes, and the probability of each outcome remains constant from trial to trial. And we have our given formulas right here that we use to come to our conclusion, as well as what each variable in our systems all mean. And in this problem, we were shown that we were successful in 8 attempts out of 10 possible attempts. So with that, we broke that down in these formulas, and we are able to show it all to you in these same percentage given here. And all right, that would conclude my Excel report. Thank you all for listening.